In this video, we're going to take a look at rational expressions and functions, this time adding and subtracting. And this gets a little bit trickier than multiplying and dividing because we do have to worry about those denominators. And just like with the fractions you've dealt with in 5th, 6th grade and in middle school, in order to add fractions, we do need to have a like denominator. So we have 4 problems to look at today. And here's our first one. And the tricky part is that we do not have like denominators. But you're going to use the same procedure you used with regular fractions. So I want you to think about this problem. What if we had something like this? What if we had 1/12 plus 1/20? Do you know what the least common denominator there would be? And how do you know what it is? So I'll give you a second to think about it, and you may want to pause the video and think about what's the denominator and why. So if you think about it, the denominator is 60, and I think by this point, for the most part, you just kind of know that it's 60. But why is it 60? Well, we need to think about the definition of least common denominator. And here is the definition. Least common denominator is the product of all different factors in each denominator raised to the greatest power which occurs in any denominator. And there are some key words here that you have to keep track of. First of all, we want all the different factors that come from the denominators, and we want the greatest power that they appear in any of the denominators. So if you think about what we had again with 1/12 and 1/20, we know that 12 is 2 squared times 3. And we know that 20 is 2 squared times 5. Well, our greatest common denominator, or least common denominator, our least common denominator is the product of all the factors, 3 times 5 times 2 squared, the highest power with which it appears. And you can verify that 2 squared times 3 times 5 is in fact 60. So that's the procedure here for finding a least common denominator. It is a little tricky to do, but these are going to get progressively more difficult, and again, we're going to look at some techniques for doing it. But again, your factoring skills have to be sharp here. So here's our problem, and I see factors in the denominator. I see powers of 2, I see powers of x, and I see powers of y. Those are the factors in the denominator, and they have to be raised to the highest power with which they occur. Well, 2 is raised to the first power only. X I see an x squared here, that's its highest power, and y has a y squared in one of the denominators. So this is the least common denominator, 2x squared y squared. And that will be the denominator that we use for both of our fractions, 2x squared y squared. But just like with fractions that we've done before, we have to ask ourselves, what do we need to multiply the numerators by in order to get the denominator that we need? So in this first fraction, we had 2x squared y. We want 2x squared y squared. So what do we need to multiply the numerator and denominator by? Well, we already have y to the first. The only thing we need is y. So we're going to multiply numerator and denominator by y, and we will have 3y here. In the second fraction, I have the y squared. I have x. I need another x, and I also need the 2. I need 2x. I need to multiply both the numerator and the denominator by 2x. Okay? And in this numerator, you can see we have a little distributive property thing going on. So we have 2x squared minus 2x. And we're all set to go. And now that we have the same denominator, it is okay now for us to add these guys together. We will have 2x squared y squared in the denominator. And on top, we're just going to rearrange these guys. We have 2x squared minus 2x plus 3y. We are all set to go. So those are now added together. It is a little bit trickier, a little bit more time consuming than the problems we had for multiplication and division. All right, here's our next one. So we need the factors here. So we only have one factor here in this denominator. That's x plus 2. But I see that this will also factor. I have x plus 2, x minus 2. So our least common denominator is the product of the factors x plus 2, x minus 2, raised to the highest power with which either appears, and they both appear to the first power. So this is our least common denominator. So both of these will have x plus 2, x minus 2 as their denominator. Now here it's probably easier to start with this second fraction first because nothing has to change. I already have the least common denominator. I don't have anything I need to do at the top. It can just stay intact. It's this first fraction I have to deal with. I already have x plus 2 in the denominator, therefore I need to multiply it by x minus 2, both numerator and denominator. And you can see that when I do that, I'm going to have a distributive property on top. I'll have 2x minus 4. The work here does get a little messy. The constraints of what I'm using to write on this is it's not the best for me keeping my work neat, but you'll try to keep your work neat and organized. But it does get a little messy, but if you keep yourself organized, you'll be in good shape. But now we're all set to add these guys together. I will have x plus 2x minus 2 on the bottom in the denominator. And in the numerator, I see I have 2x plus x, I have 3x. And I have negative 4 plus negative 3, I have minus 7. And now these are added together, and that's all set to go. Okay, let's look at two more and see how they get a little trickier as we go along. Okay, so we have two fractions here. Look a little messy. First thing I do want to do is I need to establish the factors. So I'm going to take both of these denominators, and I am going to factor them. I have x minus 3x plus 1. And I also have x minus 3, x minus 2. So the least common denominator here is the product of the different factors I see. The least common denominator is x minus 3 times x plus 1 times x minus 2. And one thing I want to point out here is that even though x minus 3 is a factor of both denominators, the highest power with which it appears in either denominator is the first power. So I only need to have it to the first power. So I am going to have my least common denominator, which is going to be real messy here, as x minus 3, x plus 1, x minus 2. It does get to be a little bit of a pain to write. Barely fits on my screen. And now I have to ask myself, what do I need to multiply all the fractions by? Here in my first fraction, let me change colors here so I can make this show up a little bit better. I'll turn to some green here. So right here, I have x minus 3x plus 1. I need to multiply the numerator and denominator by x minus 2. So I multiply by x minus 2. And I see there I'm going to have some multiplying I have to do. In my second fraction, I have x minus 3 already. I have x minus 2 already. I need to multiply numerator and denominator by x plus 1. Okay, so now my numerators, I have some multiplying to do here. I see when I multiply this first one, I'm going to have x squared plus 2x minus 8. And over my second fraction, I'm going to have 2x squared. And if I'm thinking ahead, I have plus 2x minus 3x, so I have minus x and then minus 3. Yeah, let's switch back to red again. All right, here we go. All right, so now I'm going to make it all one fraction. I have that nasty looking denominator, and I do not have to multiply it all out. That's not something I'm going to worry about at all. But something you do need to be careful about here. When I am subtracting these guys, keep in mind that this subtraction sign applies to this whole polynomial. So I have x squared minus 2x squared. That's negative x squared. I have 2x minus negative 1x. That's 3x. I have negative 8 minus negative 3. That's negative 5. And that's it. Added them together. It's real messy, isn't it? These are not the quickest problems we'll be doing all semester. Okay, one more to go. This one's fairly innocent looking, right? And in fact, there's nothing to factor. It's just y minus 2 here and 2 minus y here. And we might be tempted to think, okay, well, that might be as good as it gets. Y minus 2 and 2 minus y. And by the way, I would encourage you to write LCD for every single problem so you can see what's going on. But I'll tell you for this one, there's actually something we can do here. It's a little bit craftier. Let's see if we can figure this out together. 2 minus y and y minus 2 are actually related to each other. In fact, they're opposites of each other. Y minus 2 is the same as negative 1 times 2 minus y. They're the opposites of each other. So how can we make this happen? I would like a y minus 2 here. It'd be nice if this was also a y minus 2. We can make that happen through a little trick. What we're going to do is we're going to take the numerator and denominator of this second fraction and multiply them by negative 1. Let me erase a little bit so we can get rid of some stuff here. Multiply them both by negative 1. And that's okay, because negative 1 divided by negative 1 equals positive 1. You're allowed to multiply a fraction by positive 1. That's legal. That's the identity property. So what does that do? So the first fraction will stay intact. We have y over y minus 2. The second fraction, I'll have negative 8 over, and here's the payoff, I end up with y minus 2 in the bottom. And g isn't that nice, because now I have a common denominator, so I can just go ahead and add these guys. Y minus 2 here, and on top I have y minus 8. And that is it. So the piece of this one is, if you have two denominators that happen to be opposites of each other, you can go ahead and multiply the numerator and denominator of one of them by negative 1. So adding, subtracting takes a little bit more time, a little time consuming, but if you stick with it, you should be in good shape.